Okay, let's try something then. For this example here, we can see that it's something cubed, so we could think about trying u equals x squared plus 1, see if it works. Du dx then will be 2x, and then that tells us that dx, move that up, is equal to 1 over 2x. That comes down du. Now straight away that marks a problem unless we can get x in terms of u, which we could. So here x, if we move the u equals u minus 1, and then we square root because that would be x squared. So x is equal to the square root of u minus 1. So I equals then, let's have a look at it, integral of u something cubed times dx, which is du over 2x. But the x we can replace by the square root of u minus 1. But if you look at that as an integral, it's not made life any easier. So in this case, substitution doesn't work. So if we try substitution, we get experience of what works and what doesn't work when we do numerous examples. But if you try something, it doesn't work, and it looks like there's nothing else that we could do. So we have to use another method. Is needed here then, because substitution doesn't work. So it's not always the case that substitution is going to work, and experience will help us to see which ones will and what won't work. This one, it's not any easier. There's no clues as to how you would do that. So here, if you think about something cubed, we could just expand the bracket, couldn't we? So if you just use expansion of brackets, so x squared plus 1 cubed, let's just do that, and then we can do the integration then. X to the 4 plus x squared, so that's plus 2x squared plus 1. So that's that two brackets on the left done, times the x squared plus 1. So we'll get 6 terms come out now. 3 for the first, x to the 4, 2x to the... oh, hang on, that was x to the 4, wasn't it? Bit of a mistake there. That's a 4. So that would make that a 6, wouldn't it? Plus 2x to the 4 plus x squared. So I times through by x squared all the way through. Plus 1 of each of these. So what does that equal then? X to the 6 plus 3x to the 4 plus 3x squared plus 1. So in this case now I equals, so instead of x squared plus 1 cubed, we can just write this polynomial. And that'll be easy to integrate, won't it? So that's the best way to do this problem in this instance, isn't it, in this example. Raise the power then, simple integrals. Raise the power by 1, raise the power by 1, divide by that number, plus constant integrates to constant times x. There we go, the 3 over 3 simplifies, so I'm just going to scratch that now. That's x cubed.